All right, for this standard, I did problem number 1, which is explain how the series solution works and when you need a Frobenius instead. And we had actually done this for a quiz, so I took a picture of the quiz and I just added a bunch to the bottom. Um, so explain series solutions. We have an equation of this form right here, and we can define the y term, so y prime, and y double prime as these. The sum of a n t n, and then n a n t n minus 1, n times n minus 1, a of n times t n minus 2, and those multiply out to be these and keep going. So for this method, you have the equation and the main equation you're trying to solve, and then these to plug in. So down here, this is all I had for the quiz, but down here, I showed how you plug them in. So z times this part of the term, the y part, then b times y prime plus c times y double prime equals 0. And then you gather all the terms of the same powers of x. So this first term doesn't have an x, second one is x, next one is x squared, and you can go on and on and on, equals 0. So each of these equals 0, set them equal to 0, and you solve with these coefficients, just the constants, I did z, b, and c. It makes it really complicated to actually like plug in and do, but a lot of the problems in the book are like y double prime plus 2y prime plus y or something like that, and then a lot of times the terms will like cancel out and stuff because there'll be ones that like you can subtract from each other, and it makes solving it a lot simpler. So that's all just plug and chug, so I didn't do it, but eventually you get the terms, and I wrote right in terms of a naught, but you could write them all in terms of whatever and then solve. You get the solution of the form of a power series, so like a naught plus a naught x plus a1x plus a2x squared, and goes on and on and on. So the difference between that and the Frobenius is you would use the Frobenius for ordinary differential equations of this form, y double prime plus b of x over x y prime plus c of x over x squared y equals 0, with b of x and c of x being functions that are analytic at x equals 0. And then the solutions for these are power series multiplied by a logarithmic term ln of x, or a fractional power x to the r.